This is lesson 4 of the probability unit, and kind of ironically, this is entitled Probability. We spent the first 3 lessons learning how to count things. The fundamental theorem of arithmetic says if there's categories of things, you can multiply the number of ways. Actually, outcomes. If you look at the definitions here of the various kinds of probability, you see the word outcomes over and over again. So the number of ways something can happen are outcomes. So we were learning how to count outcomes with permutations, combinations, and using the fundamental theorem of arithmetic. So a couple of definitions I want you to look at, and then I may clear part of this space off to do a couple of problems. Probability is typically defined as the number of favorable outcomes, which is the number of ways you hope something will happen, compared to the number of possible outcomes. For instance, when I roll a die, the die is a cube that has 6 sides and has dots on it. 1 dot, 2 dots, 3, 4, 5, 6 dots on the various sides. So if I wanted to roll a 1, just a 1, there are 6 possible outcomes, but only one of them is a 1. So the number of favorable outcomes is 1, and the number of possible outcomes is 6. So the theoretical probability of getting a 1 is 1 out of 6. The theoretical probability of getting a 2 is also 1 out of 6. If I toss a coin with heads, tails, a fair coin, there are 2 possible outcomes, so the probability of getting heads is 1 out of 2. So those are some examples of theoretical probability. I'm talking about odds for a second because they're closely related, and I want to talk about experimental probability. Odds it's close to the definition of probability because you see they have the same thing. It's a comparison of number of favorable outcomes, So we're talking about getting a 2 when you roll a die, but only a 2, not any of the other numbers. There's only one favorable outcome. So the numerator would be 1 here and here, 1 out of 6 here, but there are 6 possible outcomes, but only 5 of them are not what you want. So the odds of getting a 2 would be 1 out of 5. But the probability of getting a 2 is 1 out of 6. 6 possible outcomes, so the probability of a 2, 1 out of 6. One possible outcome that we want, get a 2. And getting a 1, 3, 4, 5, or 6 is what we don't want. Those are the unfavorable things, but there's only 5. So we can get a 1, or what we don't want is, we can get a 2. Sorry, I'm just talking about getting a 2. We don't want a 1, a 3, a 4, a 5, or a 6. There's 1, 2, 3, 4, 5 things there compared to the 1. So the odds of getting a 2 are 1 out of 5. When you toss a coin, there are 2 possible outcomes. One of them would be favorable, one would not be favorable. So the odds of getting heads is 1 to 1. The odds of getting tails is 1 to 1. Experimental probability describes the results of an experiment that you do. It's if you do enough experiments, or enough trials they're called, the experimental probability, the number that expresses the value of experimental probability, will come very close to the theoretical probability. So if I toss a coin 10 times, you would predict, in theory, you would get 5 heads and 5 coins, but you know very well you could get 10 heads. But if you toss it 1,000 times, you would come close to 500 heads and 500 tails. You're not going to get 1,000 heads in a row. The probability that would happen is extremely low. It just wouldn't happen. If you did it 1,000,000 times, you'd probably get close to 500,000 heads and 500,000 tails. The more trials you do, the more close theoretical probability, the more close experimental probability comes to the theoretical probability. The fewer trials you do, you might get something that's not as predictable. Just like in sports, you may have a team who 99% of the time would defeat a certain other team, but that one time out of 100, they don't. And it might be the one time they play. They might meet once in a year, and the one time they play, that 1 out of 100 happens and the underdog wins the game. Usually they wouldn't, but they might that time. So I want to do some experiments. I'm going to kind of erase these, so if you're taking notes, you might want to pause it and get it in there. So I'm going to do, I'm going to toss a coin 10 times. I'm going to make a little tally sheet here. Theoretically, if I toss a coin 10 times, I'm going to count the heads, or predict how many heads I would get. The probability of getting heads on 2 tosses is, well, let me back up. The probability of getting head on 1 toss is 1 out of 2. So if I toss it twice, I would predict I'd get 1 heads If I toss the coin 10 times, I should predict that 5 would be heads and 5 would be tails, but I don't know for sure what's going to happen. I'm going to use a quarter so you can see the results, and I'm going to catch it and flip it. So that's, alright, that was a tails. Trust me, it was a tails, so that's one toss. Okay, that doesn't count. Heads. 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 Tails. 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 2 more to go. Heads. Tails. Okay, so theoretical probability would be 5 out of 10, but the experimental probability, the number of times that the event actually occurred, was 4 out of 10. So 4 out of 10 is pretty close to 5 out of 10, so that was pretty decent. But they're not always the same. If I would do 100 times, it would, this is off by 1/10. If I did 100 times, it would probably be closer to what you would expect. So I want to do another experiment where I will toss the die 6 times. This is doing a little tally sheet here. And I would predict, I'm going to say I want to define the favorable event as getting a 3. So the probability of getting a 3 would equal 1 out of 6. And this is a little shorthand. This capital P stands for probability, and this is just a brief description of the event. So I would read this as the probability of getting a 3, and this is the theoretical probability. So 1 out of 6 times I should get a 3, and I'm going to catch it and just hold it in my hand. And that's a 1. That's a 1. That's a 2. That's a 4. That's a 6. And that's a 3. 1, 2, 3, 4. And that's it. So the experimental probability turned out to be 1 out of 6, which perfectly matched theoretical probability. And that isn't a big deal, it just happens sometimes. And it's a good thing. So that's the quick lesson on probability. A few more details in our lesson.